Hi everyone, thanks so much for joining us this evening. My name is Amelia, I'm part of the team here at Seneca. Obviously we've got Nathan here, the main event of this evening. I'm just going to let everyone kind of take a bit of time to trickle in. I know we're still sort of a few minutes early, so if while we're waiting you want to introduce yourself in the chat, that would be fab. We'd love to know kind of, obviously most of you teach maths, we might have some science teachers here as well. We'd love to know what you teach, where you're teaching, things like that. For anyone who's just joined, we're just going to wait a few minutes, let everyone else kind of trickle in, and then we'll get started. Hi, Dennis. It's good to see you again, Dennis. Dennis was here yesterday as well. A few more people coming in now. We'll get started very, very shortly, everyone. Hi, Andrea. Hi, Jay. Hi, Angel. Oh, a few familiar faces. It's nice to see people back again. Thanks so much for coming back again, guys. Hi, everyone. Hi, Anne. Awesome. Thanks so much, everyone, for joining us on what's been a slightly rainy Wednesday afternoon, at least where I am. Oh, fab. Loads of people joining us this evening. Thanks for saying hello, everyone. It's nice to know there's people behind the screen. So I think we'll kick things off. Basically, just to give you a rundown of what's going to happen this evening. Firstly, I'm going to just talk a little bit about Seneca, really briefly, I promise, before I hand over to Nathan. Just going to show you our new maths format because we're very excited about it. After that, I'll hand over to Nathan's main speech, obviously the main event of the evening, which we're all really excited about. And as Nathan's talking, obviously, please put any questions, any comments you've got in the chat. We'll then have a whole time for a Q&A section afterwards. And then at the end, I'll also share the link to get your certificate for attending this event, because obviously it's a CPD, so you can get your certificate. And we'll also pop in kind of any other helpful links and things like that. We'll also get videos and PowerPoints from the other webinars in the series by email. We're going to send them out all together because we know a lot of people have attended all of them. So we'll send those out to you very, very shortly. Fab. So I'm going to get started and kick things off by kind of showing you a little bit of what Seneca looks like, what maths looks like on Seneca at the moment. So for those of you that don't know, Seneca is an online learning platform, all based on cognitive science, trying to basically help students learn more efficiently, more effectively by using kind of the principles that we know about how the brain works, how we learn, and retention to help make that even easier. So what we've done differently with maths now is made it much more practice focused, because we know that obviously, particularly with maths, the thing that students really need is lots and lots of practice. So as you can see, I'm just going to do some rearranging for X here. All of our math sessions on Seneca will now start with a nice video, obviously just walking students through the concept, how it works. And then what they'll get is a whole series of questions. Now, my favorite thing about these questions is that the possibilities for the kind of questions that come up are absolutely infinite. There is no limit to the kind of variety of questions that can come up here on every single one of these topics. So that means that no matter how many times a student does it, they're never going to see the same question twice. It's always going to be new, always going to be different. So they kind of got, infinite practice. Now, as you can see, I can kind of pop my working in here. Everyone's going to see how good my maths is. I'm aware we've got lots of math teachers watching, so apologies if anything is not super good. But there's obviously plenty of space to do all my working. I can work everything out here. And then I can pop in my answer. And then, as you can see, you get that automatic feedback for the students. They know exactly whether they've done it right or wrong. As you can see here, very much got it wrong. And I can see exactly where as well that I did not so well. So there's the point on the mark scheme where I kind of didn't do brilliantly. Now, one of my other favorite things about Seneca is that everything that's on Seneca is completely adaptive. So as the students go through, these questions are going to adjust to how well they're doing and either push them up a difficulty level or give them extra support if they need it. Now, if I'm really struggling, I also have this great function where I can click Get a Hin. And what that's going to do is really support students with understanding how to go through all the steps of the working out to get them really confident to be able to then tackle these questions on their own. So as you can see, it will walk me through all of the steps of the equation. So I'm collecting here the terms on the left-hand side. I can then check it, not quite right there. So I can see exactly what the correct working for that step was. I can then fill in the next one, and then the final one. And then I can get the answer. So as you can see, it's really helpful for kind of walking students through those steps. Now, a couple of other nice features is our dynamic calculator. So for any of these calculator questions, we know that students will hate having to work out the kind of answer on their calculator, then come back to Seneca. So what we've got is this great little dynamic calculator. So if I type in any kind of like equation here, so -2 -4, you can see that this equals -6 comes up, and if I press enter, that accepts it. So it's really nice and easy for students to kind of use that calculator in Seneca, so they never have to leave. They can just sort of stay in the site and keep things going. So this is kind of our main sessions on Seneca. But then the other thing I just quickly wanted to show you is a little preview of what's coming next, which is our new exam questions. So what this is going to be is a big bank of exam questions, which students can kind of work through. They'll have the full mark scheme and show students kind of where they've got it right or wrong. And these will be really good for kind of testing how well students can apply this learning and this understanding to an exam style situation. So we're really excited about where maths is on Seneca at the moment. Best part of it is all these resources are completely free. So if you want to try it out, all you need to do is go to senecalearning.com and you can try it out as a student. You can set assignments as a teacher, whatever you'd like to do. So super. So thanks so much for listening to me natter on for a little bit. And now, without further ado, I'd love to introduce Nathan. Just to reiterate, everyone, please do put your questions in the chat when they come up. I'll be keeping an eye on it and I'll be saving them up for the Q&A at the end. Super. Over to you, Nathan.
All right. I'm going to try and share some slides, which hopefully is going to work.
Fingers crossed. Always a nerve-wracking moment.
Excellent. Can you see it?
Not quite yet, but should do now.
Yeah. Excellent.
All good, Nathan.
Oh, that's the hardest bit out of the way. Just want to thank everyone for joining. I know you've probably taught most of the day and got home and decided to think more about teaching. That's really nice to see lots of people joining. And do write in the chat. Do have a pen and paper to hand. We're going to do some maths today. Yeah, I'm really excited. If I'm looking in this direction, that's because I'm looking at the chat, which I've got open on a different screen. Today we're going to be talking about interweaving, which is my favorite thing to talk about, and how it can help us make connections between different topics in maths. I think it's always good to start off by talking about what interweaving is. It might be familiar to some of you, but might not be to others. I'm going to go through it all. It is when you use questions and tasks that bring together different topics from all across mathematics. So bringing together separate ideas or separate things or things that seem separate and bring them together, mashing them up. I've highlighted that letter there in red because it's the most commonly confused thing about interweaving, which is that it's not interleaving. Interleaving is something else. I'm not talking about interleaving, I'm talking about interweaving with a W. And here's some examples of things that typically I'd have thought about when I think about interweaving. Averages with surds. You got some averages, you got surds, bring them together, averages with surds. Oh, and I really like this sort of task. I think it nicely gives lots of excuse to do lots of kind of surd calculations, lots of simplifying surds, adding surds, dividing surds by numbers, subtracting surds. You get to do loads of practice. And it also reminds you what the median is, what the mean is, what the range is. So it brings together those topics, gives lots of practice of both of them. Some other ones. Could solve linear equations that have standard form in. Why not? So even A-level things like doing trigonometric equations with a factor theorem. There's loads of opportunities for bringing together different topics that might seem disconnected and then asking questions that mix them all up. Even reciprocals and equations. Why not? Lots of different topics. Now, when I thought about why do this, I'll admit I kind of did this after I decided it was a good idea. I tried to think about why it's a good idea. I came up with 5 main things. Number 2, because we're obviously going to start at number 2, is retrieval. We all know the importance of retrieval and do lots of things maybe in starters or in homeworks, but it can also be done during lessons, like in the midst of while you're learning new topics. So you can bring back those old stuff that they did a term ago, a week ago, a year ago, and mash it up with what you're doing currently. That acts as that retrieval. You're less likely to forget what the median is. If you've done the median of surds, when you did surds, you did the median of numbers in standard form. When you did standard form, you did the median of some fractions. The more times you come across these ideas, the more likely you are to remember them. So retrieval, really helpful. It allows you to really go in depth on topics and not just kind of treat them superficially. You have to really understand surds. You can't just have a kind of superficial, surface level understanding if you're going to be using them to find averages or sequences. You really test that understanding. What also gives great challenge, it allows you to really stretch those high attainers. You can really make things hard yourself. You can't rely on just familiar numbers coming out with nice answers. You've got to really understand what you're doing. You can make really hard questions using interweaving just by bringing in horrible numbers or bringing different topics or things that have multiple stages. It also gives a bit of a purpose, maybe potentially a bit of a pseudo purpose to what you're doing. Like you might think, have pupils asking when you're learning about surds, why are we doing this? When am I ever going to need to add surds? When am I ever going to need to multiply surds? When am I going to need to subtract surds? And you can say, well, you're going to do it when you need to find the median of some surds, obviously. You can give purpose to what you're doing. Now, it's not really a real world purpose, but it's something. Now, you might notice a number missing from that list, and that is the number 1 thing. And I think it is the most important. It's what I'm going to talk about mostly this evening. And that is making connections. Interweaving allows us to show the connections that underpin all of mathematics. And I think that's one of the things that separates how I see maths most from how my pupils see maths sometimes, is I see it as this subject full of connections and underlying principles, a really consistent subject where everything happens for a reason. You can always understand, go down the next layer, and eventually you'll get to 1 add 1 is 2 or something like that. It's a fully connected subject, whereas our pupils, I think, sometimes don't recognize that. They see a expanding brackets question and think that looks nothing like a volume of the cone, a cone question. They seem completely different. Interweaving allows us to make those connections to help pupils recognize the structures, the ideas underpinning what they're doing. Now, just like to talk about that challenge one again, because one of the things I think I've done wrong with interweaving in the past is using it primarily for challenge almost, thinking, oh, this will be a way to stretch my top set. They're doing equations, everyone else is doing equations, but we're not going to do equations like them. We're going to do equations with standard form in them. And I think that has its place. I think it does help stretch those high attainers. But I think interweaving is even more important for those that might not be so highly attaining in maths, because they're the ones most likely not to see those connections. They're the ones for whom they're most likely to see maths, these separate subjects, half of which they've forgotten. So quite the opposite should be the case. I shouldn't be saving up my interweaving for when I'm teaching that top set. I should be using it with those that need it most, that most are starved of that understanding of the connectedness of maths. So that's why I'd like to focus on that today, is how we can use interweaving with those with low prior attainment, with those that find maths a real struggle. And there is a bit of a danger in that, because interwoven questions, interwoven tasks are quite hard. They are quite hard. So I've tried to be thinking, like, how can I structure these sorts of tasks, these sorts of questions, in a way that they are accessible to everyone and everyone can then reap the benefits of them. And that's why I came up with the idea for, well, I say came up with the idea, it wasn't my idea. That's where I recognized the use of a slightly different form of interweaving. In the past, I've called this interweaving in rather than interweaving out, that I'm not bringing in a load of random topics just to for the sake of interweaving. Just, oh, I'm going to chuck surds in. I'm going to chuck decimals into the question. Not that there's anything wrong with that, but I'm actually searching for the connections that are already there to bring those out. Now, one topic that's great for that is proportional reasoning. One topic, great proportional reasoning. Proportional reasoning underlies so much of what we do. And pupils don't always see that. They don't always see that because they can look very different on the surface. There's this percentages question. There's a fractions question. We've got a probability question, a similar shapes question, a graphs question, and have a speed, distance, time question. All of them on the surface look really different. But if you unpack them a bit, you can see that the maths is the same in all of them. They're all really the same question, apart from one. Hence, I put in the middle there, which is the odd one out. Now I'm going to give you a bit of a minute, maybe less than a minute. Have a think about all those questions. Try and spot the one that's the one that's the odd one out. Try and see why they are all kind of the same question. Do put it in the chat. I do have the chat open. If you spot one that's an odd one out. Now, hopefully you've noticed that the answer to lots of these is 6. Like 18% of that number, definitely 6. 4/12, that's the same as 6/18. The length of that triangle, 6. The x-coordinate of that graph is 6. Even that probability question, I think, if I did this correctly, there should be 12 counters there, 4 of which are blue. 4/12, 18 times. I think that'll be 6 as well. Now, it's interesting to see lots of different answers coming out in the chat. So thank you those for putting answers in the chat. It's actually Johnny. Johnny is my odd one out. Well done to Laura for getting that one. Johnny's the odd one out. Yeah, that wouldn't be 6 miles. He'd go a lot further than 6 miles in 18 hours. And it's really important to recognize because sometimes people don't really recognize the depth of this. It's not just that all the answers are 6. They're all 6 for a reason. They're all 6 because they're the same question. All of them are looking at proportionality between 12 and 18 and comparing that to the proportionality between 4 and 6. Or looking at the proportional relationship between 4 and 12 and the corresponding relationship between 6 and 18. And I showed this to, we looked at this in a department meeting that I was in. And my colleague that was leading it realized that you can put all of these on that graph in the bottom middle. You could label these axes to make them work with every question. I could label it with like the percentage versus the number. I could label it denominator versus numerator. I could label it with probability or proportion or number of counters and the number of times that counter was picked. All of them kind of linked together. I even made this animation. It was a slightly different format for the question, showing how those triangles can fit onto the graph. And you can get that length of 6 being that same as that x-coordinate being 6. And there's really nice questions you can ask here to develop this. Like you won't, if you just show these 6 questions and have them work out the 6 questions, go, yep, all 6, let's move on. You're missing out on so many opportunities. I like to talk about 3 and what 3 represents in all of these. And that's quite a weird one because 3 is not a number that appears anywhere, but 3 is fundamental to almost all of these questions. It's the scale factor between the numerator and the denominator in the fractions. It's the gradient of the line in the bottom middle. It's Johnny's speed when he's walking. That's a really important number. 1.5, also really important. 1.5 you can see in that fraction. It's what you multiply to get from the first fraction to the second fraction. It's the scale factor in your similar shapes. There's lots of other questions you ask as well. You can say, which one's the odd one out? Correct it, fix it, Make it so it fits with the others. It's also something I find myself referring back to. I've just come back to this time and time again when we've done another topic that has another bit of proportional reasoning. I think I've done like 15 questions, all with 4, 12, and 18. Loads of opportunities there. Have a look at these 6 questions. These 6 questions all hinge on that just simple times table that 3 times 4 is 12. All of them rely on that one fact. In question 1, that becomes your common denominator. In question 2, you're just asking what times 3 is 12, and obviously 4. In question 3, you've got that area, 3 times 4. In your percentages, you've got that multiplication of 3% times 400, or if 1% is 4, 3%, 3 times 4 is 12. Showing in that ratio, you're scaling up from a total of 4 parts in a ratio to a total of 12 pounds, multiplying 4 by 3. When you expand the brackets, you're doing 3 times 4. Now, once again, if you just show these 6 questions to your pupils, I don't think they'll really pick up on it. I don't think they'll necessarily get it. They might kind of see that 12's appearing quite a bit, or 3 and 4 are appearing quite a bit. I don't know if they'll really see that all of these are relying on that multiplication. So you kind of got to force them to. One way to do that, change the numbers. Change the numbers. This way, they're kind of forced to use that multiplication fact. Can't get away with working them out all individually as much. Like, you don't really want them doing 1,440 divided by 32 to solve that equation. You want them using that fact. I was thinking still, nevertheless, they might just kind of skip past the thinking and just go, well, a lot of them mean 1,440, so let's just assume there's a 1,440 somewhere. Or maybe that wouldn't make sense for that percentages question. Maybe it's £14.40. And we don't want them to avoid thinking. We want to force them into the thinking. We want to force them into the thinking. One way of doing that, just changing the question slightly. Just changing the question slightly. That way they're forced not just to recognize that they're using the fact, but to adapt the fact to what they want. The 1,472 should be in red. I do apologise. It's a mistake on my part. But this way they now have to think, well, I know that 32 times 45 is 1,440. What does x need to be so that I get 1,472? When I'm expanding those brackets, I've got 31 lots of 45x, but I don't know what 31 times 45 is. I know what 32 times 45 is. Lots of different ways you can think about this. Just going to answer a few of the questions in the chat. There was a question about how the animation was made. It was on PowerPoint. If you do the animations on PowerPoint, you can then export to a GIF. What do you notice? What do you want? It's an excellent, always a great pair of questions to ask. Yes, it might make them not use the lowest common denominator of the fraction. In some cases, I can live with that. The purpose is, yes, it's to recognize that multiplication happening. And absolutely right, Dennis. 45% of 33 is 33% of 45. And in this case, that is a definitely useful fact to be able to use. I'd rather find 45% of something than 33%. Although if I was approximating, I might prefer to find 33%, as I'll know it will be just under 15 in that case, because I know 33% is about a third. So this is looking at how you can really develop an idea from finding instances where you have to multiply to forcing pupils to recognize that underlying multiplication, all the way to not just recognize the multiplication, but using it and using their understanding of multiplication to answer these slightly adjusted questions. So in each of these, I'm trying to find those ideas that are underpinning different topics, and then finding the questions that can bring them out. I think that it's like, if I'm imagining the maths curriculum as a tree. Often pupils deal with the leaves of the tree. This is trying to bring out the branches of the tree. And absolutely right, as we asked in the chat, students feel confused often when you're doing these sorts of questions. They need the discussion. They need to work it through. They need to talk to each other. They need to talk as a class to try and work out these ideas. And you need to scaffold it. You need to give the hints and support where it's needed. This isn't just a task to let them go on with on their own in a cover lesson. It's something that's to be talked about. Something that brings up a lot of questions. I love this question about scaling up rather than division. Absolutely right. Scaling up, such an important thing to be able to do. And scaling up and division are kind of the same thing in many ways. At least that's how I see it often. Right, next one. I'm going to, again, just pause for a minute here and give a bit of time for you to have a go at these questions. Give a bit of time to have a go at these questions. Try and recognize what's commonality, what's underlying all of them. Absolutely right, Dennis. They are all the same question. They absolutely are. And what I like about this is on the surface, they don't look it. They don't look at all. I've got random polystyrene cups. I've got a taxi. I've got sequences. I've got graphs. I've got triangles. And I've got kind of function machine sort of things. But they are all the exact same question. They're all that linear relationship. In the sequence, I've got 3x plus 4, or 3n plus 4 is the nth term. The graph has equation y equals 3x plus 4. My taxi fare, my call out fee is £3, and then it's £4. Then it's £3 for every mile. In that function machine, that one that says multiplication should really be multiplied by 3, and that addition should be add 4. In my triangle and my squares, again, the triangle is 3, the square is 4. These all bring out those same ideas. Even the cups, that lip of that cup, even though it's not quite to scale, the lip of the cup is my 3 centimeters, and the bulk of the cup is the 4. Now, once again, we're coming back to this idea that if you just showed these 6 questions and had to go at them, pupils wouldn't necessarily pick out what you want them to. They wouldn't get the meaning from it. We've looked at a few ways we can help them get that meaning. One was by having I'm going back a bit. One was having the which is the odd one out. I like that one. Have one that doesn't fit that you can then try and make fit. We looked at ones where maybe you force them to do it by giving whole numbers or by slightly adjusting it so they need to use the underlying structure. This one I'd ask a question like this. Change each question to make the answer 43. That forces pupils, again, I'm using forces, it sounds very aggressive. That prompts students to understand the structures, see which bits are coming up from where, because there's 2 10s in every question, and the 10s are very different. In the top left one, it's the 10th term, but the second term was 10. In the second one, there's a 10 in the y coordinate and a 10 in the x coordinate. In the third one, there's 10 miles and 10 pounds. There's 10s in every question, and they mean different things. So it's not enough to say, well, to have the answer be 43, well, currently the answer is, I should have worked this out in advance, it's 3n plus 4, so 34. Currently it's 34. I need 9 extra. So maybe it's the 13th term. Maybe it's the x coordinate be 13. You need to then work out which of those 10s are you changing, because you can't just change either 10 to a 13. You've got to change the right 10 to a 13. You've got to understand that structure to be able to use this fact. Now, one thing I like about these, and these took me quite a while to come up with these numbers particularly, is that just changing the 10th term to the 13th term, or changing the x coordinate being 10 to 13, or changing 10 miles to 13 miles, or changing 10 triangles to 13 triangles. That's one way of doing it. But you can also change each question a different way. That's one I think it's a bit hard to spot. You could change the other 10. Now, I might have done this wrong, I can't remember. But I think if you change the other 10, so if you change the second term to 11, or change the second coordinate, the y coordinate, the second point to 11, or if you change the 2 miles to 11 pounds, I think if you change that, it also works, keeping it the 10th term. That will also give an answer of 43. Because instead of getting 3n plus 4, you get 4n plus 3. So I like that you can do each one in 2 different ways. So there's lots to explore with these. And my running theme is still there, that you need to be discussing this. You need to be exploring the ideas. We're not just thinking about the questions on their own. It's using the questions to come up with the underlying structures. You're absolutely right, Laura. It should say arithmetic sequence or linear sequence in these questions. I was prioritizing brevity over precision. Now, this point, I think it's worth thinking about the difference between different presentations of an idea and different topics themselves. These all have different ways to present an equation. In the top left, I've just got equation. In the top middle, I've got how to think of a number approach. In the top right, I've got kind of a function machine. It took me a very long time to find a perfectly curved arrow, so I do appreciate that, please. You've got kind of a bar model or tape diagram in the 6th one. In the 5th one, you've got kind of a weights or balances or mobiles, and you've got kind of algebra tiles in the bottom left, although you'd need a lot of algebra tiles. Now, these questions, they don't all have the same answer, but they should pair up. I'm at least 50% confident that they'll all pair up. And that's another way you can do it. So we've kind of seen 4 different ways now that you can use these tasks where it isn't just solve the questions. We looked at finding odd ones out. We looked at adapting them to change the solution. We looked at pairing them up. Looked at being given a result and using that result. So this is another way that you can take these sorts of sets of questions and make pupils think about them really properly. So those are 6 different presentations of solving equations. But you can also have 6 different topics where those equations could come up. You can do those angles in a straight line, perimeter of a rectangle, sharing in a ratio, an isosceles triangle. I'm so sorry I couldn't be bothered to draw an isosceles triangle, so I just described it. And again, using that linear equation. Now, the top middle one isn't one I'd use necessarily with a particularly low attaining group, but it's a nice one. I quite like, because the length of that side is a horrible surd, or a nice surd, depending on the point of view. But the area is quite a nice number. And if you kind of form it, if you don't solve it backwards naturally, if you form the equation first, you do get hopefully the exact same 6 equations as in those 6. But again, might have messed that up somewhere. Now, I'm seeing a few questions in the chat, which I'm going to answer. I'm so sorry I'm ruining the Q&A for the end, but while I'm seeing them. There's a nice discussion happening about scaffolding and how you can deal with mixed attainment. I like both ideas that, yeah, you can scaffold it up so that everyone's accessing the same task, or you can easily make these more difficult or more easy to help certain individuals. I think both are absolutely fine. And what I like about them is they allow any individual to go in far more depth. Like such an easy extension is come up with the 7th question. Or in this case, if they pair up, adapt the questions to make them all match one of the pairs. Loads of different ways to stretch these or to scaffold them. Really flexible tasks. And the tasks are one thing that's really helpful, but I think the mindset is even more valuable, that whenever you're planning a lesson or thinking about a lesson, the thinking about the underlying structures, the underlying ideas, and how you can draw out and really get people to recognize those connections. Because it's not enough just to say it. It's not enough just to kind of see it. People have to wrestle with it, wrestle with these ideas. Now, I'm coming near the end of what I've got prepared. I'd just like to give a bit of credit to Paul Rawlinson at Pondering Planning in Mathematics. He's got an incredible blog post called Using Numbers to Highlight Connections. And that's doing a lot of what I've shown here, showing that by using questions with the same numbers, and that's not the only way to do it, but it's definitely one way of doing it, you can draw out these connections, you can make these connections more obvious. And he's got some lovely examples in there, I think with histograms and things like that to show, especially density as an idea. So there's lots of really nice ideas in there. Now I want to leave some time for you to do some reflecting on your own. I've done quite a bit of I do. I think it's time for a bit of you do as well. So do use some of this time just to be thinking through what maybe you've got coming up that you're teaching, what things you taught in the past. If you're doing revision, maybe with year 11s for mocks coming up, could you give them something like this and revise lots of different topics at once? That's how the proportion questions I think I did started, looking at all the different ways proportion was coming up and doing revision. And think about your lower attaining pupils. How can you make them recognize what's so obvious to us, that all these things are connected? But yeah, thank you very much for listening. I really appreciate it. If you go to my website, which is interwovenmaths.com, you can see a lot of interwoven tasks and some other tasks as well. There's lots of things on there at the moment. It's recently been revamped, so it actually loads when you open the link. I'm also on Twitter at NathanDay314. I think that's me done. So if you want to start the official Q&A, please do.
Amazing. Thank you so much, Nathan. That was awesome. I've never seen something quite like that. I thought that was absolutely fascinating and such a cool way of teaching those multiple topics together. I know we've had, lots of questions coming up as we've gone through. But any kind of more general questions, more specific questions, any questions really, anyone, all cues are welcome at this Q&A. Please do pop them in chat. I've just seen one come in from Millie asking, are there any topics you would say where you can't use interweaving?
I always feel like that's a challenge. I think I'm going to go with no. I think you can interweave anything. However, some are more annoying than others. As you can see, I'm quite lazy with making diagrams and things. So yeah, but no, I think every topic in maths is connected to other topics. Like it is one big tree. There are always underlying branches and there's always connections there to explore even stupid topics like plans and elevations that don't even belong in the course whatsoever.
Brilliant. Also, I don't think anyone could say that your diagrams and animations are lazy, but there were some very cool ones. I saw a mum put in the chat earlier which sort of software did you use to create that triangles one where the triangles went into the graph?
PowerPoint. Everything's on PowerPoint. I can't do anything else.
Nothing wrong with a classic. That's my approach. Any more questions, guys? Please do feel free to pop them in the chat. I think Angel popped in a question asking what's the workload like for creating these kind of questions. Obviously you've got a whole bank on there, but I think if someone wanted to create them themselves or anything similar,
I'd really encourage people to create their own. I think I've got as much out of creating them as pupils have got when I've used them. Just forced me to think about things, also, like I started all of those basically within the last 24 hours with a blank screen with 6 boxes. I'm like, oh gosh, I've got to come up with 6 things. But when you think about it, you can come up with those things, and there's connections that now are so much part of what I do and how I speak that would never have come to me before I started really thinking about it. I think it was Charlotte Hawthorne that made me think about sequences and graphs and how they're the same thing. And before that hadn't really occurred to me. And now it's just part of how I teach the topic. So the more time you spend thinking about it, the better. I think they don't need to be perfect. A mistake in a set of questions can easily become a deliberate mistake as a discussion point. They don't need to be beautifully typed. You can divide up a board into 4 or 6 and write up some questions. I don't think it takes too long.
Super. And we've got another one from Angel as well, saying, what's the toughest connection that students seem to be able to spot?
Oh, that's a great question. I think a lot of the proportional reasoning stuff is pupils find really hard to think proportionally. We're so used to thinking additively, where things add up. Thinking about that proportionality, that when something doubles, the other thing doubles, but you can't add 2 and add 2. I think that's such a, maybe it's not the most confused, but it's the most important one that's often confused. There's an incredible video from the NCTM where they discuss a spring problem, where a spring's been stretched, and where does the blue and red dots, and to me, I'm watching it going crazy. I think it's the most obvious thing ever. If you stretched it twice as long, then it's going to move down twice as far, but pupils can't wrap their head around it. It's really non-intuitive, unintuitive, counterintuitive. Oh yeah.
I like that. That's amazing. Yeah, Angel agrees with that on proportion definitely being a tough one. Dennis mentioned that like this kind of technique can also be used for spot the mistake, which Giles also chimed in with.
Absolutely, definitely. A spot the mistake would be a great version of it.
Super. And then we've got another one on suggestions for differential equations and possible connections there.
I've got no suggestions, sorry. I've not taught differential equations. I'm sure there's lots out there, though, if you think about it.
Super, a challenge there. Awesome. I have a quick question just about, because I think this is a really awesome way of engaging those like lower attaining learners, like you mentioned. But I was wondering if you've ever had students just really be completely unable to wrap their heads around it on first chance, and how you've kind of tackled that to help them access this.
I think a lot of that is question choice. That you want to choose questions on topics they've done, and ideally topics they're good at. So ideally they should see them separately before they see them together. This isn't where I teach these topics. These will come usually towards the end of when they're learning about a topic. So hopefully at that point, at the very least, they should all be able to answer the 6 questions. If they can't answer the 6 questions, then change the questions. And then you can use those as the launching point for discussion and see how far you can take it. And I do a lot of that just playing by ear, just reacting in the moment. Like if they're spotting connections really easy, like that's a great opportunity to adapt something. If I change this to this, what will happen to that, and so on. So yeah.
Brilliant. Yeah, I think that's a super way of doing things. Got another one. Dennis is going to try this with all years, not just years 10 and 11, which is super as well, because, and I think it got mentioned earlier in the chat as well, like very easy to adapt for different age groups for teaching.
And definitely, the sooner they see these connections, the easier they'll find things later on, and they'll spot more and more and more in it. It'll roll. If they're seeing this in year 11 when they're revising their exams, they might have like a light bulb moment that could have come years earlier. So definitely starting early, but they are good in year 11 as well for revision. So.
Super. And also I love this from Dennis, discussing maths is just as healthy as doing it. I think that's a super way of thinking about it.
Absolutely, and that's what I like about these sorts of tasks, and they're very different to ones that I usually use, and that is that there's so many opportunities for discussion, I find. I think on the proportion one, I think you can even see it in the top right of the screenshot on the screen, there's the 6 questions in the middle, and then there's like 8 different prompts around the outside for things that you could talk about. There isn't just the questions. The discussion is bountiful.
Amazing. So there's a lot of love in the chat coming in, like a lot of thank yous, and a lot of people who are going to apply to their teaching, which is super. Obviously, any more questions, please do pop them in the chat. But I'll sort of start to. Oh no, we've got a good one from Giles. I won't start to wrap up. We're going to address Giles's question. So Giles asked, do you tend to use whole class discussion, pairs, mini whiteboards, etc., or a mixture?
All of them, all of those, definitely. I think the bulk of it comes in the whole class discussion, I find, because that's where I can lead things in the way, point towards the things that I want to point them towards. But paired discussion is great for preempting that. Mini whiteboards are fantastic. I definitely would do these with mini whiteboards, just so they can try out things, it's easy to rub things out and then take them, which is really good for the adapting sort of questions. So definitely all of those.
Amazing. Super. So yeah, please do continue to pop any questions in the chat as they come up, but just while the last ones filter in, just to reiterate a big thank you to Nathan. This has been so interesting. And also, if this is the first of our series that you're catching, there's still 2 more webinars which you can also see on our channel. So please do go check them out. We had some amazing speakers, and also a big shout out to Maths Week England. We're really excited to have been part of it. It's still obviously going on. We're only on Wednesday. The Seneca webinars may have finished, but Maths Week England certainly hasn't. So please do go check out their website as well. And for anyone who would like to get their certificate for attending any of these webinars, you can get one for each of the episodes that you've attended. I've just posted in the chat the link there. And what's going to happen is we're going to send out a big email to everyone who's attended all of these webinars, and that will include all the links to watch them again, because I'm sure there's been so many like nuggets of gold in all of these webinars that you'll want to go and have a look back on some of the other ones. So we'll send out all those links. We'll send out the resources that we've spoken about. So for instance, Nathan's website with all of his amazing resources on there for interweaving, so that you can use in your own class, and things like Kaleem's website from yesterday's webinar. We'll send all that out. And also a link to get in touch with you and questions about Seneca or Seneca and maths in general. So in that case, unless there's any more questions, Nathan and I will hang around for a few more minutes in case there's any more questions. But other than that, I think we'll leave everyone to get on with their Wednesday evening.
Yeah, and thank you so much for Seneca for hosting this. It's really nice to get the opportunity to talk to maths teachers.
Maths teachers are super. It's definitely a good opportunity. Amazing. Looks like there's no more questions coming in. So I think, Nathan, we'll say goodbye.
Excellent. Thank you.
Fab. Thanks so much, everyone. Have a great rest of your evening.